This episode of Photonics Hot List is brought to you by Aerotech, precision motion control and automation. Take control, speed, precision, performance.
Hello, I'm Justine Murphy with Laser Focus World. Let's take a look at some of the amazing things happening in photonics. Significantly faster internet, more efficient imaging systems, and potentially the full realization of quantum communications are all now within reach, thanks to a mix of 3D printing, silica glass sensors, and optical fibers. Researchers from the KTH Royal Institute of Technology in Sweden have 3D printed silica glass micro-optic sensors onto the very tips of optical fibers. Specifically, the process produced a refractive index sensor to measure the concentration of organic solvents like acetone and methanol at near IR wavelengths. This was done without corroding those solvents, a common problem with sensors that are based on plastics and other polymers. Conventional processes require high temperature treatments to remove carbon from the glass and make it transparent. In this work, a non-carbon-based material was used instead to yield that same transparency. The KTH team's approach doesn't compromise fiber coatings either, which are extremely sensitive to high temperatures. The researchers say their 3D printing technique, as well as the combination of the robust glass material and plug-and-play aspect of optical fibers, could aid the advancement of things like fiber communications, optical MEMS systems, and fiber-integrated quantum technologies. The unpredictable nature of earthquakes makes it difficult to forecast and monitor them. A new fiber-optic gyroscope sensor could change that. Designed by a team at the National Optical Institute in Italy, the prototype gyroscope sensor offers real-time, high-resolution monitoring of seismic movement and rotations prompted by volcano activity. The new sensor is based in part on the Sagnac effect, which occurs when light that's traveling in opposite directions around a closed loop shows different travel times. Initial testing of the rotational sensor in an active volcanic area in the Campi Flegrei region of Naples involved injecting light into a fiber-optic cable just over a mile long. The cable formed a loop and inside an uninterrupted light path. Over the course of about 5 months, the technology recorded data, including noise and ground rotations, continuously with high accuracy. At this point, the gyroscope sensor is a single-access system that can only measure 3 directional components of the rotational movements. The researchers are working to improve that with the development of a 3-axis setup that could ultimately improve risk assessment and early warning systems. A new form of nanodots has the potential to expedite the development of smart technologies and a host of other electrochromic and photochromic devices. Researchers from Shandong University in China and the University of Alberta in Canada have created tungsten trioxide nanodots. Now, those nanodots' chromatic properties can be fine-tuned with some simple adjustments to size, crystallinity, and surface ligands. The nanodots could make possible rapid color switching in electrochromic devices, which control things like optical transmission and absorption continually and reversibly when electricity is applied. The researchers say that essentially, these nanodots allow dynamic transparency control and boosted electrical energy storage, an ideal setup for things like smart windows. The new technology could also enhance the coloration speed of photochromic effects, in which a color reverses when exposed to light. Such effects can be found in photochromic hydrogels for sealants, as well as in textiles that would be well suited for smart clothing. The team is now working to further enhance the tungsten trioxide nanodots and scale up their production. And that's your Photonics Hot List. Be sure to like and share, subscribe to our YouTube channel, follow us on social media, and visit laserfocusworld.com for the latest and coolest news and information. And check out our Following the Photons podcast too, to hear some really cool, interesting interviews with the industry's top players. Until next time.